we've got the angle bisector theorem. And with this one, I want you to draw an angle. Cut that angle in half, because that's what the bisector does. So that means okay. And we're going to make perpendicular from the sides of the angle. Make right angles here and here. Okay, and this one works both ways as well. Another buy one, get one free. So the theorem says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So this right here would be the angle bisector, which make these congruent, right? And if we have point X, remember this is the side of an angle and that's the side of an angle. So what the theorem says, since X is on the angle bisector, and we know that because of these, that makes X equidistant from the sides. So that gives us those congruent. Okay, the right angles should be there regardless of whether you're using the theorem or the converse. If you don't have the right angles, you can't use the theorem. But back to those congruent triangles, okay? Without these two pieces marked congruent, can you see that these two triangles are congruent? If you use the reflexive piece, you would have angle, angle, side, yes? So if the two triangles are congruent, then naturally any other parts that are corresponding would be. That's what makes those congruent. Okay. Now sometimes I have had people who understood the proofs, even though that wasn't necessarily the explanation I was looking for. If someone wanted to take the route of saying the triangles are congruent by angle, angle, side, that's why, you know, X, Y, and XZ are congruent, for instance, I'd be thrilled with that because you're really getting at the heart of why they're congruent. You're going the proof, you wouldn't have to do a proof. But if that was part of your explanation, that would be fine, okay? But one way or another, you're either citing the bisector theorem or the converse. Converse I'm going to make a little bit shorter. If a point is equidistant from the sides, then it's on the angle bisector. You're not really going to be naming these theorems. Again, it's the concepts that you have to be familiar with. The buy one, get one free part is if I have those right angles and those pieces congruent, I get those congruent angles. And the other way around, if I have these right angles and those congruent angles, I get these parts congruent, okay? And that just happens under CP/CTC, really, because one way or the other you can prove that the triangles are congruent. So how we use this, and I'm sure you're going to find this pretty easy if you're good at algebra. Again, the explanation part is where people usually struggle, okay? So a couple examples. Okay, if we are finding the length of FD, remember without any notation with it, they're talking about length. In order to find FD, you have to figure out what X is first. Okay, now remember, we said that those and the right angles, the buy one, get one free part, kind of buy two, get one free, but that gives us these being congruent. Okay, so if those are congruent, at that point you can set them equal. 5x equals 2x plus 24. The rest is algebra. So we have 3x equals 24. X equals 8. And what do we do to find FD? I just found X, but that's not FD. Okay, the quick way, I'll tell you, is these are supposed to be congruent, right? And we set the equation up as if they were. If you multiply 8 by 5, that's supposed to be both of these lengths. That's really the quick way. So these should be 40. If you want to test that, 8 times 2 is 16, plus 24, also 40. So using one or the other, since the length is the same, but you do have to plug X back in. All right, so up here, 5 times 8 is 40, or you could do it over here. 16 plus 24 is 40, but they are the same length. Okay, so the markings we have the congruent. So basically these 2 points are equidistant from that line. And we have the right angles. So what does that give us for free? The whole explanation part, and let's call that, I think in the book that's K and E. K is equidistant from, I think I have D and H. K is equidistant from ED and EH, which means that it's on the angle bisector, right? The whole equidistant part is part of the explanation. If it's on the angle bisector, that means those angles are congruent, and once you know that they're congruent, you can set them equal. Now I'm going to throw one other piece in here because I want you to see how people mess this up a little bit. I've had people with problems like this go, oh, 2x must equal 10. Can an angle equal a side length? No. You don't want to mix up your angles and your side lengths in the same equation. Doesn't work. If you're setting up an equation, it should be either with 2 angles or 2 sides, not mix and match. So 2x does equal x plus 20. Okay, and the rest is your algebra, so minus x. So x equals 20. If you had to find your angle measure, of course you're going to plug that 20 in. 20 is not the angle measure, it's only the variable. So the measure of angle KED equals 2 times 20, or 40. So both of those angles should be 40 degrees. Okay. They might also ask you to find the length of KD. That's kind of a gimme. All right. So there, in this section, there are not, You shouldn't be adding things up to get something else. Okay, most things here are congruent. The bad thing about this is then when you get to other things that you have to add up again, you're used to just setting things equal. You want to be really certain you understand the relationship before you just go setting things equal. Okay, but a lot of the buy one get one free parts in here are, once we identify what we're looking at, they are usually congruent. Okay, so your homework is 1 through 25. Okay. When you're dealing with variables, like algebraic expressions, please make sure you write equations down and show work, because those are typically the ones that I'm going to include on the homework quiz.